Good afternoon, guys. Uh, nice to meet you all once again. It's actually I always get a pretty awesome energy whenever I come to like a React Bangalore meetup. Thanks a lot, Kiran, for like organizing the meet. And how many of you guys were part of my previous talk? Can I get a show of hands? Okay, cool. So there's like a lot of new audience. So what I was actually doing in the last two talks, basically I was like doing like a series of uh, sessions on how to like optimize your React application as you are like building. So the previous talk, the first session was about like islands architecture. So the whole idea behind the islands architecture is how you can add interactivity only to specific parts of your web application. So there we discussed about Astro, Next.js app directory, and I think today also there's a Astro.js talk, so it will be like really good. And second talk was about SSR on the edge, and this talk actually covered all the rendering patterns that is like available in the React ecosystem, and we covered like certain SSG, SSR, and client-side rendering, all those, and the talk basically like ends up with saying why you should like do SSR on the edge rather than like a traditional node environment. So the common thing among these two talks is that both of them focus on like reducing the load on your application on the browser. So if you look at Islands architecture, it focuses on reducing the amount of JavaScript that you are like shipping to your users. And if you look at SSR on the edge, it focuses on moving the complex logic out of the browser into your servers so that your application naturally has like lesser load and eventually it performs like really better. But there are like scenarios, rare scenarios where you have to like build a very JavaScript heavy applications on the client side. And that in that scenario, like Islands architecture or SSR on the edge doesn't really make sense. And this talk is actually targeting that specific category. That's why it's like optimizing large applications. Because in usual normal applications where you are like building hundreds of components per page, you won't generally need much optimizations because React on its own with its virtual DOM is like fast enough. But this talk focuses on like understanding how that virtual DOM works and what are the scenarios in which the virtual DOM is actually like not good enough. We have to think about further optimizations. So it might go like little advanced and might cover topics that might not be like needed in your day-to-day development. But anyway, it's always fun to learn as we are like exploring new things. So hope I will be able to like convey the concepts clearly. Cool. So how many people here know what is virtual DOM? Yeah, this is a React meetup. Obviously, everyone will know. So I just put a reference link there. You can go and refer what's a virtual DOM. We can skip over that. But here is the thing. Virtual DOM is fast for most cases until your users like start noticing a little bit of problem. So usually what happens is when you're like bootstrapping an app, building a POC or like building a new product, your application will perform really fast. You would think, okay, this is gonna scale really well. But there'll always be like a few pages in your application. What will happen is whenever the user starts using that page, whenever they are like doing a drag and drop or like some kind of animation is playing, they will notice a small lag. And the performance will start to be more noticeable as your team starts adding more and more components into the application, because right now we build design systems and we have like different teams managing like different products in the same application. So what happens is you take a small paragraph, that paragraph will have like hundreds of components within them. Like the bold text will be a single component, then icon will be a own component. Even a small hyperlink will have its own component where on hover you have like some pop-ups and stuff showing up on the hyperlink. And with the team size increasing, what happens is the amount of DOM elements will also concurrently start increasing. And given you are building an app like Google Docs or app like Figma, where the app has to be like an SPA with like full single page experience for the whole user, there is not much we can do with the Highlands architecture or the SSR. So what we actually have to do here is, there is an interesting blog written in Svelte framework. Like virtual DOM is a pure overhead. So they will talk about how virtual DOM is fast, but technically it adds a lot of overhead to how you are like updating your JavaScript DOM element. Okay, so instead of like going over to the virtual DOM and reading that blog, I thought I'll make a very small app that explains how virtual DOM is a overhead for your application. Okay, and again, since this talk focus on like building large applications to simulate performance issues, I also had to build a very large application. So I just split that into two parts. One, I'll have a small application that tells why virtual DOM is a overhead, and another large application where virtual DOM will actually perform really slow. Okay, so let's start with the demo of our small application, where I'll basically show you guys why virtual DOM is considered a overhead as your application scales. So this is the small application that I built. So what this application has is, it's a small animated box that just moves left to right. And let me also show you how this box component is created. So this box component is built using Framer Motion. It's a nice library for building animations. And what happens is, I have an animate function here that repeats an animation infinitely, where in each cycle it reverses the flow. And this is the animation value. So the animation value basically has transition across the x-axis. So the box transforms along the x-axis as time passes, so you will see that left to right movement. Now, if you look at this values that I have added, so what I did is, when it renders, I made sure this box is picking up random values between the values 20, 50, minus 10 to plus 10. So every time the box is rendering, it's going to render with a different animation value, which means the animation will not look smooth as your box starts re-rendering. So let me show you what it looks like. Now, dragging the slider will basically like edit the number that is inside that box. So as I drag the slider, you will see that animation basically starts like, the box has like a flickering effect because the box is re-rendering. And technically this number is the one that is supposed to change, but since the number is supplied to the box as a prop, if you see in the box's props, the value that is inside is available as a prop, and whenever it changes, it forces the component to re-render. Cool. And also it has a selected state, so when I select it, it turns red. Okay, I'll tell you why I have this state. So next what I'm going to do is, I built a small catalog. So what this catalog contains is, it has like hundreds of such boxes. And each of these boxes is going to have some value inside, and I have an input field here. So one input field is a range selector, which is that dragging interaction that I showed. And another is going to be a text field, which will let me select a specific box from the entire catalog of these animated boxes. And what I did is, I built a small context. So this is kind of a pretty normal thing in React. Like whenever you want to like pass state across different components, you build a context and you make sure these components can get the state updates from the parent without any need of prop drilling. So just created a small context. And using the context, I can pass the selected value to the box so that the box knows, okay, I am the one that is currently being selected. So this is how the application will look like. Now you see a whole catalog of all of these boxes animating. By default, the selected ID is 0. Now let me change it to 12. So the box number 12 has been like selected. And when I am like dragging this slider, technically what should happen is, this box's value is supposed to change. Correct? Now if I look at my code also, you will see I am using the context and I am giving a selected ID, and only if the ID is selected, I am passing the value to the box. Otherwise the box doesn't receive the value, it only has the ID, which means technically other boxes are supposed to be unaffected. Correct? But here's the problem with the React context. What happens is, so as I am like adding my value, it will start re-rendering my entire DOM. Does it make the application slow? Not exactly, because it's a small app. It needs a much bigger scale for you to like actually notice the difference. But now, what is actually happening is, behind the scenes, there is a heavy DOM computation going on. So as I am like starting changing the value, the application is behind the scenes computing in the virtual DOM. Should I need to like re-render this DOM or not? Got it? And whenever it takes a call to re-render it on the virtual DOM, a re-render happens, but it is not applied to the DOM, which means the final end HTML element has not been affected. Still, there has been a computation that actually involved the entire application, which means somewhere on your JavaScript thread, a process is going on, and that process is taking up unnecessary complexity. As your application is growing, these kind of complexities tend to compound. Cool? So this is the default behavior of context. Like there's like an ongoing thread, like how can we make context like a little faster so that the unaffected elements can be like optimized a little better. But trust me, don't use UseMemo. I just had this tab here just to tell you guys, don't use UseMemo, because what I have seen many teams do is like put UseMemo on every place wherever they had to like avoid re-renders. But there is a hidden cost of having UseMemo, because what happens in UseMemo is as you are like adding dependencies and a calculated value, those values will start adding up to the memory complexity of your application rather than the main thread complexity. So as your application is like increasing in size, the amount of memory complexity needed for each UseMemo also will start growing. And technically like re-render has been prevented, but the weight has just been like moved to a different place. You will run into a different kind of complexity by using UseMemo, use callback, pretty much any of these things. And large amount of UseMemo also means your code gets like little complex to maintain, because developers have to be aware what are all the dependencies that UseMemo have to be like added, what dependencies need to be like removed. And in a large application, it gets out of hand eventually. So React team is actually working on a new compiler which automates the creation of UseMemo internally. So over a period of time, this is going to be like completely taken care of by React team itself. But still, the new compiler also like falls short in like one area. So this is a blog in builder.io where they are explained about React's upcoming compiler. So what they have mentioned is UseMemo is supposed to like prune re-rendering, and it actually works for most scenarios. But what happens is as your state is being prop drilled, when the parent component has to change, right, regardless of how much UseMemo you have, it will still lead to re-rendering. So this is a situation where I was like not able to create a perfect example for you guys to see, but I'll leave the blog post in the end of the presentation so you can go and give it a read. So how do we like solve this problem? So we know like we need to like re-render like only one box, but kind of like re-rendering the entire set of boxes. So what I did is I used a third-party state management library. In this case, I'm going to use a tool called Zustand. Zustand or Zustand, not sure how to pronounce it exactly. So Zustand has like a small section here that tells why use Zustand over context. And here there is have a point saying renders components only on changes. So in Zustand, we can be a little smart and make sure only the component whose prop is going to be changed can re-render, and we can skip re-renders on all of those components. So I rebuilt the same catalog now. This time I built it with Zustand. Now the catalog will remain the same. It has the same input fields and the same simple box component. But one small change here is if you look at my box data, I have like 4 values in my Zustand store. One is like an ID value and 2 setters for ID and the value. And the input field will use these setters and update the value. And when I am like getting the value, okay, it has a regex selector kind of syntax here. So what happens is I need the box data inside my animated box component. I am like writing down, I need the box data, but I don't need the entire state. I only need the value of the state. So I am returning it as state.value. And I am also adding a condition here saying, only if the ID is the selected ID of the box, then give me the actual value. Otherwise, just give me -1. So now what happens is, as long as the ID is not the selected ID, it will always return -1, which means a state re-render is not needed. But if it is a selected value, it will return the value that I have chosen on the store's state. Now let's look how the application behaves with zoo stand in its place. So this is the zoo stand version. Now let me select a different ID. Let me go with 16. Now, if I like to like change the value, what will happen is only that component will re-render. So here you can see by slightly like modifying how I am like passing the state across, I can actually like reduce a huge load on the virtual DOM, which basically like React has to do a state DOM comparison only for that specific element. And in a real world scenario, these kind of optimizations go a long way, because you might inadvertently like rendering a whole DOM tree of your React application, and suddenly you limit your re-renders to a specific part of the DOM. The performance tends to be like extremely visible. But right now, if you look at that blog post that I shared, they did mention another alternative on the right side after UseMemo, saying there is a concept called signals. It can prune rendering, and it can also like take care of rendering even if the props have been like drilled through. So signals is a very new concept and also a very interesting one. This was introduced by a framework called Solid.js. And signals were known to be like extremely fast, because unlike states are basically one value and one setter. So you pass the value down the DOM and you call the setter, and React will re-render the entire DOM node. But the way signals work is it has a getter object and a setter function. So now what happens in signals is, if you create a value out of a signal, that value itself is a function. That function can tell internally, this is the DOM element I am situated in, which means for any change, make sure you are directly updating the DOM. So now we are kind of moving away from virtual DOM and starting to update the direct DOM. Kind of feels counterproductive, like aren't DOM updates supposed to be slow? That's why we created the whole virtual DOM. But here's the fun part. If you are doing a fine-grained DOM update, like you know where the values are and you are exactly going to update the value on that DOM element, they tend to be much faster than the virtual DOM. So instead of reconstructing the whole DOM, like virtual DOM is like doing a diff and everything, instead of a good comparison I can say is, instead of like searching through n elements in an array, you are using a hash map and just referencing it by the key. So that makes signals really fast. This concept goes beyond the virtual DOM. Let me also show you. I obviously made one more version of the catalog. This time it was built with the signals. So it's the same selected box ID and selected value, and this time the values are like wrapped under signals. And these signals are right now available, and it was made by Preact. So they have this very interesting blog post explaining how signals are like really great, and there is like one nice screenshot that I can show you. Let me go to their blog. Yeah. So this is the comparison of the JavaScript thread with the virtual DOM and with the signals in a really large application. Right now, Preact supports signals really well, and React also has a signals package. So this is the React version of this signals package. So I just took it and recreated the whole application. This time what I'm doing here is, I am passing the signal value. So you can see in the TypeScript inference, it's not a number, it's a signal object. And I will pass the object to my DOM element instead of passing it as a plain number. And everything else is simple, exactly the same. I have like an input field where I am like setting the box value, and on change I am updating the value. No difference over here. But the beauty of signals shows up when I am doing the same experiment. Now let me select a different box. Let me select like 18. Now if I do any update, you will notice that there is like no jitter anywhere, because like there is absolutely no reason for the React component to re-render. I am doing a fine-grained update on that exact DOM node where the number is present. So if you are like learning about doing an optimization and you want like a quick win, you can always obviously like turn your states into signals and start optimizing it, but it comes with its own limitations, because signals are good at only changing the DOM values, which means if you are doing any kind of computations, then there is another primitive called computed. You will have to take that one and create computed signals. That I think you can learn from the documentation. It comes with experience, but there are certain caveats also you have to like know. And the fastest way to learn signals is I'll tell everyone to go and build a new project out of solid.js, and you will know how good signals are, and you will actually hesitate to start using states again in React. Now let's get back on track. So the thing is, now we are gonna like simulate a really large application, okay, that is like actually slow and like struggles to re-render, and we are gonna look at how the actual virtual DOM works in that scenario. So what I did is, I took this example from one of the open source projects. So this is the component. So what I'm gonna do is, I have a display component here. So it's gonna display a multiplication table, a normal multiplication value. And what it will do is, it will, along with the number, render like 100 DOM elements that are like practically empty. So it renders 100 such DOM element. And what I'm gonna further do is, that is for one item, I'm gonna repeat that process 2000 times. That is like 2000 into 100. So I'm gonna like render a drastically like huge DOM element with zero optimizations. I'm just gonna go with virtual DOM. And let's see how the whole application like performs. And you will also notice a lag radar added on the page. So that radar basically like shows activity on the JavaScript thread. So that spinning radar that you are seeing, so every time it's having that yellow or like red color pattern, it means DOM update is happening and the application is actually lagging, which means any interactivity on the page will actually like causes the application to slow down. Okay, it has finished rendering all the items. So what I'm going to do is, I'm going to start a timer and have React update all the DOM nodes. Now if you look at my code, I am like being very explicitly clear, saying that I only need this item, this DOM element to be like changed, and these are like not exactly like DOM nodes that needs to be changed. But what will happen is, React will still try to like compare them internally through the virtual DOM. So what happens is, as I am starting a timer and the count starts, you will see for every render how long it is taking. So for every render, it's like taking 0.9 seconds, and the average is around 0.8. And for every render, you will see that red color flicker saying that, okay, it's actually taking a while for it to like do this render. So how do we like optimize this situation? So ideally, the easiest way to optimize this scenario is, make sure you are reducing the number of DOM elements in your application, because by being smart, you can like actually bring the amount of DOM elements to a considerable extent. Because internally, React has to like construct this 2000 into 100 DOM nodes on a virtual DOM, and has to like manually do a reference check across every single one of them, which basically like makes the entire application like slow. Right now it averaged around like 0.78. So I was like thinking about it for a while, like how we can bring it down, what was the community working around it. And there have been like very interesting projects. So one interesting project was a different virtual DOM algorithm. It's called a block DOM. So how this algorithm works is, it converts each DOM element into an independent block, and make sure it only compares reference equality of that specific block that has been changed, thereby bringing down the amount of comparison by a lot. So it has like a tutorial on how to make your own framework. So I was like following this tutorial along. So it teaches you how to build your own React-like framework. So he builds a framework called Tomato and has the same state, render, and all of this. So I was like trying this, but unfortunately like ran out of time. I had to like prepare the example. But there was another interesting project called Million. So Million.js is a alternate virtual DOM library. So right now this is, I think, being sponsored by Vercel, and this actually took inspiration from Block DOM, and right now it is like available to use. So what Million.js does is that it lets you convert your React components into blocks directly on the code. So now let me go to that block DOM implementation. So Million.js basically like introduces this wrapper called block. And using the block, what I can do is I can wrap a component inside that block. So the component that was displaying my value, right, is actually like displayed as a block. And here you might think why I'm like printing the values instead of doing the computation directly on the component, because technically I can do I into count, it will print the value. But I wasn't able to do that because once I convert everything to a block using million, what will happen is everything will become an object. They are no longer like proper numbers that I can multiply. And by making everything into an object, million can actually like reduce the number of comparisons it has to do to update your DOM. So I went back and built the same application this time using million. So no difference, I just wrapped the entire display using a block DOM. And it takes a while for it to render. There's like so many DOM nodes it has to render. And it takes a while. Okay, cool. Now if I start the timer, what I can see is, let's hope it is like actually performing better this time. Cool. It's like alternating between worse and better. So previously it was like consistently at 0.9. Now you will see that this is like alternating across 0.2 and 0.8. So it does its best to like make sure it is optimizing the number of re-renders across. So as the timer runs, you will know the average, how it is like optimizing it to a certain extent. Now, once again, this is a concept that you won't like have to implement every day in your work, because this happens only when your DOM like grows into like a different magnitude. But it's always a good thing to know how the virtual DOM works, how we can like leverage different concepts like signals, zustand, and even like different rendering modules, which will make sure you can like actually do better as you are like reaching that specific scale. Okay, so that pretty much like concludes the talk. And this is pretty much all the tools that are like used in the talk. I'll make sure I share this directly on the React meetup page. And in case anybody wants to like connect with me on Twitter, you can like follow me on this handle. I'll be more than happy to like answer your questions.